Okay, perfect. Really exciting. The last talk before the closing keynotes. What an amazing conference. I have to admit something. When I was young, I told my mom that someday she will see me in the cinema. I didn't expect this is the way it's going to happen, but I'll take what I can get. A word from the conference. We will be doing, like in all the talks, Q&A at the end. So please go to SlideU, put the code, write your questions during or at the end, and then we'll be going over them. Just before we kind of start, maybe just to warm up and get to know each other, with the raise of hands, who here uses data on their day-to-day? Okay, we got some hands. Let's try something harder. Who here is willing to define themselves as a data professional? So that means that your day-to-day revolves around data. You are a data engineer, data analyst, data infrastructure engineer, machine learning engineer, right? Okay, not that many hands, great. So this talk is gonna have something for everyone. So don't worry if you're some of the more advanced people in the crowd. And also it's gonna speak for people that don't really know this, and this is where we're gonna start. So we got to know all of you. It's only fair that I'll introduce myself as well. My name is Josef Goldstein. I'm working at a company called Wix. I assume all of you is already familiar with that, but just in case you're not familiar with Wix, Wix is a platform for building websites and online businesses. At Wix, I am leading the R&D group that's responsible for our data engineering and analytics platform, or the way I like to call it, big data platform. This is not a talk about Wix. This is a talk about data architecture and big data in general, but I will be using some examples from how we're building things at Wix throughout the way. This is also a good chance to tell you guys, and I'll put this again also at the end, that we're holding a meetup in our offices here in Krakow next month. It's also going to be data-centric related, together with StarTree. It'll be about real-time analytics. We're going to have Team Berglunds. We're going to be really, really cool. So, this talk is about data and data architecture. Now, when I talk about data and data architecture, I like to split the world into two: the analytical plane and the operational plane. So what is the operational plane? The operational plane is the place where we store the data that is used by our operational systems. So imagine that I have a microservice, and that hopefully is some kind of a domain-bound microservice that manages a certain functionality that is part of the operation of whatever it is that I'm building. And more often than not, behind that microservice is going to be some kind of a database. That is my operational data. That's the data that I am using as part of running my business operation. We are not going to be talking about that. Most of the talks about data today and the previous days in GeeCON were about the operational data. What we are going to talk about is the other side, the fun side, the analytical data plane. Now, to kind of explain what is the analytical data plane and why do we even need something besides the database we use to run our microservices, we need to talk a little bit about how modern companies and modern businesses work, right? So it used to be kind of a buzzword, but now it's becoming more common for companies to say that they want to be data-driven. Anyone here is working in a data-driven company? Okay. Anyone here knows what data-driven even means? Less hands. So that's how usually it works. To kind of explain what it means and why companies, and especially modern companies, are looking to be more and more data-driven and therefore being pushed to having a lot of data analytics, let's talk about how businesses work. All right, so let's go to the beginning. Let's put computers aside, software, internet, all of that aside, right? The old school form of business looked something like this: a brick and mortar shop. So if I was the owner of a shop, a real one, right, not one in Amazon, and I want to know how to correctly manage my business, I use the very sophisticated tool which is called my eyes. I look at what is happening inside the stores. I see the people coming and going. I see which time they're coming. What are they looking into? What do they buy? What do they not buy? Which parts of the store they're not going to? And where am I losing opportunity? I can even talk to them, and I can ask them, what would I do that would make you come here more or buy more, right? How can I improve my business? But this is true for brick and mortar stores, for the old school type of business. Most businesses these days are online. And when your business is online, it looks more like this. Now, we're not only talking about stores, right? We're not just talking about the e-commerce stores, the type of stores you can build on Wix, for example. When you think about it, most SaaS companies, right, software as a service companies, most cloud-based companies, are a business. They are a business that has no eyes, right? And then comes the question of, okay, if I am blind because I can't see the people, I can't feel them, I can't talk to them, how do I know how to evolve my business? How do I know where to make the investment? Now, when we talk about internet scale, the numbers also make a difference, right? So if I have a brick and mortar store, maybe on a good day I can get 100, 200 people coming into my store, right? That's numbers I can manage. Like I can see these people, I can talk to them. When we're talking about internet scale software, when we're talking about internet scale businesses, cloud businesses, we're talking about millions. If we're talking about things like social networks, we're talking about billions. Now imagine Facebook going to the 3 billion users that they have and ask them one by one, do you like this? Do you like that? Do you like this? Should I do that? Would you like that? Would you click the ads more if I did this and that, right? That is impossible. So the only way for us to get a good approximation to understanding how these businesses look is through data. It's through data analytics. It is our eyes, and it is the eyes for most modern businesses, especially at internet scale. So let's say you're convinced. The first question you should ask yourself is, okay, I understand, I need to have these fancy graphs and probably things that are slightly smarter than graphs to understand how to run a business, but where's the data, right? So think about the system that you're working on today, the company that you're working in today, right? Where is the data? The data is inside all of those operational systems, right? In those microservices, in what's happening on the user's browser. This is where we have the data that tells the story of what is actually happening. And then comes the second question is, okay, cool, I understand, I think. How do I get this data? And this is where it gets ugly. So this is a kind of really rough way of showing things, right? But in many ways, what I'm going to show you now explains how this works in most companies today. So on the one hand side, we have our developer having the best time of his life. And he or she are working on building the business, right? And it can be writing microservice, some client application, it can be anything. And that system is managing all that data that tells the story about what the business is doing, right? So they're storing that information in some kind of a database, right? Database that microservice is using. Maybe they're storing this data in some awful third party that they're using, right? But the data is there. On the other side, we have our data professional, our data engineer, data analyst, data scientist, machine learning engineer. And they try to get this data into their playground, into their sandbox, into the analytical data store, the place where we analyze the data and make data-driven decisions. So how do we get from one place to another? What we usually do is the simple thing. We copy the data, right? So ideally, not directly from the operational database, that usually ends badly, usually from a replica, right? Once in a while, I'm going to write a script. The script is going to harvest the data that was created now in the database. I'm going to copy it into my analytical data store. This is something that's usually referred to as an ETL. There's a few other acronyms for that in different forms. It's a short for extract, transform, and load. Basically, I am extracting the data from the replica, hopefully, of the operational system database. I'm transforming it, or maybe even not. And then I'm loading it. I'm putting it into another data store that's meant for analytical purposes, something like a data lake or a data warehouse. If I'm cool, or I have the need to have the data more up to date, right? Because if this is a script and I run it once a day, the data is pretty stale. I will use something called the CDC. So a CDC is short for change data capture. It's actually something that is implemented by most modern databases, and it is a standard for a database to communicate over events, changes that have happened in the data. So imagine for a second, I'm doing an insert of a raw into the database. The database is going to emit a log event that says, a new row was created in the table, and this is how it looks. I do an update. Again, an event is emitted saying a row has changed. And I can tap into this stream of events using something like some kind of a streaming platform like Kafka, for example, and then consume the data. Again, maybe do some transformation on it, maybe some not, and write it into my analytical data store. Now, this might sound okay. It kind of works, right? We get the data from our operational system. It does tell the story of the business. But something kind of nefarious is actually happening here. Because if you look closely, what you realize is that what we're actually doing here, we're tapping into the implementation detail of a system in a way that was never meant to be used, right? That developer never thought that the database that sits behind several layers of abstractions of that microservice that he or she are writing, someone's going to take that database, copy it, make all kind of assumptions about it, and then use it for making decisions on how to run the business. What essentially this is, and again, this is how it works in most companies today, this is a data recycling center. It's the equivalency of going into someone's trash, sifting through it, and hoping that you can somehow reuse the stuff you may see there for something else. Now, we are all green, we really like recycling, this is fun, but when you want to base the business decisions that you're making on that, probably not such a good idea. By the way, can anyone spot the data engineer in this picture? Let me help you, right here. Oh, sorry. Do we have any data engineers in the house? Yeah, so I hope you relate. But what's the problem here? The problem here is that we are using the exhaust, the byproduct of our operational system in a way that was not meant for before to build something new upon it. And that's usually a bad idea. So what are the problems that we have with a data recycling center if we double click on that? The biggest problem is that there's no defined contract, right? At no point did we have any agreement between the developer on one side and the data professional on the other side on the data that they're going to be sharing, right? So the developer or the team the developer belongs to are the domain owner, right? They understand the domain that their software manages the best, but they don't have any agreement with the person who's going to be consuming this data. And what does it mean? Let's imagine that I have a database, and in the database I have a column, and that column is an integer. I might make some change that will be completely meaningless in the system because, again, everything is behind several layers of abstraction. But that column might be an integer, and then I change it into a string or a cat. And if someone was gathering this data behind the scenes and made all kind of assumptions like, yeah, this is going to continue to be an integer forever and ever, they're going to be very, very sad when they realize this is going to be a cat. The other problem is we've actually made data lore. So the only way for you to actually understand how the data looks is to read the code of that script that copied it. The only way is to read code or SQL, which some people would argue is also code. But we don't want it to be this way, right? If we want to trust data that we use, if we want to treat it as a product that we're using to make decision making, we want it to be explicit. We want it to be well defined. The third problem, and this is kind of a sneaky thing, is what I like to call the raw data fallacy. So a lot of people that manage data had the tendency to believe for a while that if I just take all the data that exists inside my product, that's going to be enough to tell me the story of what's happening in the business. But that's not necessarily the case. To give you a hint to why that is true, imagine that the question that I need to answer is which countries our customers are coming from? Or which countries do we do well in? Or which countries do we not do well in? That is implicitly means that I need geolocation information. Now, if nowhere in all those databases of all my operational systems I have geolocation data, then that data is useless. I have to have the information that I need, or maybe something that I can derive it from, like an IP address, for example. And the last one, this is usually ad hoc-ish. Every microservice, every new domain component is a different story. It's a different beast. If every time I need to go and relearn how the data looks behind the scenes, the implementation details of the systems, it means that I will never be able to reuse something that I built. Every time that I need to get a new piece of data, a new table, a new copy of a database, I will need to relearn everything and rebuild everything and then maintain it. And then when that integer turns into a cat, when you have 1 or 2 or 3 tables, that's maybe something that's manageable. But when you're talking about larger scales, larger companies, companies that have hundreds of domains, thousands of microservices, then it becomes something that's not scalable. And the sad part about all of this is not how data looks for most of the software world. Think about it. We have been using for years things like APIs. What are APIs? They are interfaces used to interop data and commands between two components in an agreed manner. We know that if someone exposes an API, that's part of their product. And if they break it, it means something. So why can we not do the same for how we're doing analytical data? Essentially, what we would want to do is to take all the area, the gray area in which we're taking data that was not meant for analytics in the first place, data that is the implementation details of our systems, and we want to get rid of it because that's the danger zone. What we want to do is we want to shift left. We want to shift left the responsibility for creating and owning this data that we're going to be using for analytics. We want to create analytical data as a first-class citizen in our software architecture. So how are we doing it? And this is the core focus of what we're going to be talking about right now. And this is data contracts, or more specifically, domain-driven data contracts. So data contracts are not a new concept. It's a way for us to describe the agreement between two parties, or multiple parties, a producer and multiple consumers, on the data that I manage or represent within my domain and willing to expose as a product. You can think about it as an API. When I'm building a microservice, for example, and I'm exposing a RESTful API, I am telling the world, this is what I'm giving you. This is what I know how to do, and I guarantee that this is what's going to work. What we want to do is we want to create the same thing for our data. But if we're smart about it, we also realize that it's not enough just to define how the data looks. We also understand that we want data to be available as fast as possible. Because as data becomes available faster, so are the opportunities, so is the value. So we don't want just to have data contracts. We want to have data contracts for streams of data. We want data contracts for events, right? Event-driven data contracts. So how does it look in practice? Like, what does it actually mean? Okay, and data contract's fine. I have a contract from my mortgage, whatever. What does it actually mean, right? So again, we're going back to our developer having the best time of her life. And he or she now decides to expand the domain that she is responsible for. And now, as one of the concerns that developer is going to take care of, as part of doing that, is together with our data professional, the data consumer on the other side, define a contract. Try to explain in data terms what data is being managed, owned, and governed by this domain entity, a microservice, for example. Once we do that, we want to take this information in an actual form that we can use, not just write it on paper, right, in some kind of a usable form, and put it all in some kind of a registry or a catalog. Why? Because we want to have a singular place where all of our domains and all the domain components that we have register their contracts. Give you an example. At Wix, if you were in Nathan's talk 2 days ago, he's talked about us having 2,000 microservices. What does it mean? It means that this is a registry that should have at least 200 data contracts. And those data contracts as a whole tell the story of our business. And once we've done that, and hopefully we've done it well and in a standardized way, then we can do some interesting things. For example, we can automate the consumption of this data, right? So that we don't need to be ad hoc-ish anymore, right? Because if there is a way for me to know how the data looks and where it is available and whether I can trust it, then maybe I can just write something that consumes everything pretty automatically, right? And I can take away all this ad hoc-ish work. Why? So I have some time left to do some fun stuff. So how do we do this in practice? So like I said, this is not a talk about Wix, but I will be talking about 2 strategies and a little bit of how we are implementing them at Wix. And I will be also talking about how you can implement it at home. So don't worry about that. The first one is domain events. So domain events is also not a new concept. This is a quote by Martin Fowler from a decade ago. So the way he describes it is domain events are events which capture the memory of something interesting which affects the domain. Now, what does it mean? Let's imagine that we have a domain component. Now, what is a domain component? It's an abstraction. That can be a microservice that manages a specific entity. So let's take an example. We talked about the brick and mortar store. If we put that in the virtual domain, then we're talking about microservices that manage e-commerce. So for example, a domain can be the domain of e-com. If I'm thinking about a smaller domain, that can be the domain of a specific entity, like a shopping cart. So a domain component can be the microservice that manages the shopping cart entity and all the things that I'm able to do with it. But it doesn't have to be a microservice. A domain component can be a subcomponent in a monolithic service. It can be a Lambda function. It can be a batch script. It can be anything that runs within our holistic system architecture and is responsible for a specific domain within it. And then, when we're going to be building this component, we're going to be thinking about what interesting things are happening in the business use cases that we're coding, and we're going to be emitting events that tell the world about this. So for example, if my domain component is a shopping cart, I might have an event that says a new shopping cart was created. I might have an event that says a shopping cart was updated. I might have an event that says a shopping cart was abandoned. Now, it doesn't have to be necessarily a change in the entity. It can be something logical or a business activity that happened. For example, we had an entity and no one did anything about it for 10 minutes, so now we're sending a notification that this was probably an abandoned shopping cart, right? Or it can be a callback or anything that tells something interesting, in this case about the world of the shopping cart. Now, once we know what these events are, we can tell the world about how these events look, so the world will be able to consume these events. Now, why is that a powerful concept? Basically, it allows us to create interoperability with other domain components, as many as exist, without being coupled to them, right? So we're sending asynchronous events. We're telling the world how those events are going to look, and basically we're telling the world, look, my guarantee is this is how the data you're going to get looks. You can consume it from here, and from that point on, it's up to you. And that way we can create decoupling, but still we can have those systems depend on each other. Now, when we talk about analytical data, these events, if they're comprehensive enough and they tell enough the story of everything that's happening within each one of these domain components, they are essentially the data contract that can tell us in an event-driven way what is happening right now. So how do we leverage that? So again, telling the story of Wix, but this is not specific for Wix. When a developer starts writing a new microservice or updating an existing one, even before writing a single line of code, the first thing that we do is we write the service contract. Now, a service contract can contain many things, and it really depends on what you need. In our case, it contains usually 3 main things. So the first one is the definition of the domain entities. What are the entities that this domain component or this microservice manages? So for example, if we're talking about a microservice that manages shopping carts, what is a shopping cart? How does a shopping cart look? What fields does it have? What is the meaning of these fields? What restrictions do these have? Right? How the data looks. That's obviously is going to translate into APIs, into events, and also eventually into how we're going to be persisting the data in the database. The second thing are the domain actions. These usually will translate into APIs, things that you can do, right? Or asynchronous. I get a message and I perform an action. And the last one are the domain events. The events that I'm going to emit and tell the world so they will be able to react on things that happen in my domain in a decoupled way. So we chose to implement this using protobuf, and it looks something like this. So if you zoom in for a second, it's basically a non-software development language specific way to describe the data contract. So in this case, for example, this is the event for a shopping cart being created. Right? So the syntax here is protobuf syntax, but that's just an implementation detail. What we actually have here is a definition of the domain entity in all of its fields. And we also have documentation, right? We have comments that translate into documentation. So I know that this is the meaning of this field and this field and that field. I'm also going to be reusing the same domain entities to make sure that they're cohesive. So for example, if I have a sub-entity called the buyer info, I will use the exact same one, same as I would reuse a data class. Why? Because I want the data to look exactly the same on every type of domain event that I'm generating. Now you can go below that and go further into that and add semantic information and data validation information. So you can, for example, say, for my buyer information, the identifier has to be in a UUID or GUID format. So if you're sending me something that doesn't look like that, I'm not going to accept it. But we can go further than that. We can add semantic qualities for that. For example, I can say the first name and the last name of the buyer, that's private user information. That's a user identifier. It's a PII. So it means that if I'm handling this data, I can think about that. Maybe I want to encrypt this data. Maybe I want to omit it completely. Maybe I want to take this into consideration if I save it somewhere, because now I need to consider it in terms of GDPR. So once we define this contract, and again, we haven't written a single line of code yet, unless you call prod buffer code. Now is the time to actually implement the service on the contract that we define. Once it's ready, at least in the version of it, we can take this contract and we publish it. We can publish it to a schema registry. In our case, we implemented it, but there are schema registries that exist out there. I'll talk about it later. But basically, every microservice of those 2,000 services publishes their contract in that schema registry. And then the thing you can do right for having one central system in which all components report how their data looks is to create a glossary. Documentation. Imagine that. You have a for how to look in your organization across domains. Something like this. Very similar to how Swagger looks, by the way, when you think about API. Obviously, right? So this is human visualization. That protobuf we saw before. We have a part event creation event. This is the field, how they look. Here's a sample of the data look. And more than that, if you consume this, here's the topic you can consume it, because we use it as our platform. And even more important that this has an owner, because the service has an owner, because the domain has an owner. Hopefully it's a team, not a very person. But it means if something's wrong, if I'm not getting it based on how I expected it, or missing something, I know who I need to talk to. Again, it goes back to left the ownership and the responsibility. Now, obviously, the next step after that is automating it data question pipelines. Because if I'm able to create this for a human, I can also create it for a machine. So I can now expose the entire catalog, all those contracts, into something. And because they're all built in a unified topic where the data is, here's how the data is going, here's the validation rules, I can automate the action. So I can either do something that's bespoke and say, I just want this specific event, and then create some kind of a single message transform, or I can just do it in bulk and say, give me all the data contracts that exist in a company and start consuming all of them. And eventually drop it in a cohesive way into our analytical data store. So if we're talking about the shopping cart data, basically what it means is we've built a microservice that manages the shopping cart. That microservice now emits domain events for everything that, every action, every interesting thing that happened in the domain of the shopping cart. And each one of these events is now captured automatically by a pipeline in near real time, because we are using streaming technology, and write them into a table. And now I can have a table that says shopping cart created, updated, abandoned, so on and so forth. And then the next thing I can do, because again, what am I trying to do? I'm trying to create the eyes that I'm lacking, right? I want to create something that is like being in that store and seeing people managing their real shopping carts. So the closest approximation, looks like this. All right, this is a funnel. It's a funnel of the life cycle of a shopping cart. A shopping cart was created, updated, and then bought. And this obviously can update in near real time, because as new transactions are happening, as users are performing more actions in the websites, this is generating more events in the backend. Those are being streamed and updated into the data source that eventually feeds into this. And when we look at it, we can see that we have a problem, right? We actually are losing a lot of potential customers somewhere between the managing and adding to the shopping cart and the actual buying part. And now we can do something about it. We can try to understand why is this happening and change our business. How does it look in terms of architecture? Pretty straightforward, actually. So like I said, we have the domain microservice on the one hand. Usually in our case, there's a service that's built either in Scala or in Node.js. And as part of the CI/CD pipeline for that microservice, we're going to be capturing the service contract and the data contract published by the service and publish it into the registry. Either a new one, if a new service is created, or updating one, if we're evolving an existing schema. And once that service is up in the air, it's actually free to start generating those events based on what's actually happening. And in our case, that's based on Kafka. And then what we can do on the other hand is create a pipeline, in this case built on top of Spark Streaming, to collect all the existing data contracts, see what topics, in which topic which data exists, and then automatically connect to all of these topics, consume the data, verify this data against the contract that was expected, right? Does the data look like the contract said? If this is a UUID, is this field actually a UID? And even do more interesting cross-cutting concerns. So for example, if we want to emit or encrypt PII data, then encrypt it. Maybe we want to add more information on top of it, doing enrichment. For example, adding more information about the user or about the session, right? And eventually, we can land it into our data lake. In our case, our data lake is based on AWS S3, using Parquet files and the Apache Iceberg table format. Obviously, this is a lot of stuff we build ourselves, and that kind of brings the question of, cool, I understand Wix allows a lot of people to work on these cool things. How am I supposed to do it myself? So there's nothing that does everything. This is actually, especially in the world of data analytics, this is still something that's slowly growing. I would highly recommend looking into Async API. So Async API is a relatively new project that is aiming to be what OpenAPI is for RESTful HTTP APIs for asynchronous communication. The original reason for this was actually to create those contracts for microservices to communicate with each other, but actually this is extensive enough that you can use it to define full-fledged event-driven data contracts by services. And the beauty about this is language agnostic, right? So you basically define the contract, in this case using YAML file, and then you can use this YAML file to generate data classes in various programming languages. You can also get cool things out of the box, like generating those HTML web pages, like the ones that I showed before, something that looks like Swagger, but for this. And also, to a certain extent, integration into all kind of common schema registries out of the box. So highly recommend to look into this one. Once you've established that, you will kind of need to decide on what is the format in which you're going to be creating the data and defining the schema. So we are doing it using protobuf. Avro is another great choice. And you can obviously just use JSON and use JSON schema to define those schemas. And you will need to have some kind of a technology for the schema registry, right? The place where you're going to register and update all of those data contracts. You can obviously build one by yourself. If you're using Kafka, Confluent, schema registry is kind of an obvious choice. But there's other options, either open source ones or ones that are available as part of cloud provider services. Now, I said before that we have two strategies. And that was just one. And there's a reason for that. If you think about it for a second, what we tried to do before is to analyze what's happening in our online business. And we discovered that we're losing a lot of our customers before they actually click buy on their shopping cart. And we want to understand why. But that information might not exist in our domain components. Now, why is that? It's very possible that the interesting thing is actually happen on the browser right, on the browser of the user. The information actually might be related to how did the user arrive to us to begin with. Did they come through Google search, through an ad, through something? And this is where the second strategy comes into play. So unlike the first one, which is we're saying, let's architect well our domain and tell the world about what's happening in it, in this case, we're saying, let's understand what data we need and instrument for it. So I like to call this analytical data instrumentation. The way I describe it is predefined business intelligence events and telemetry explicitly collected at the source. So what does it mean? In this case, we're actually not starting in the domain owner. Right? We're not starting in the developer that owns a microservice. We are starting with the person that is looking for the data. We're starting with the questions that we want to have answered. For example, why are we losing customers before they buy in the shopping cart? Or what are the sources from which we get users where we get the highest conversion? Then we say, okay, what data would we need, either collected on the client side or the server side, to answer these questions? And once we decide on that data, we say, okay, this is our analytical data contract. And you, please, domain component owner, I want you to implement this. So basically, what we're asking is for the domain component owner to instrument the creation of this data. What does it mean? Think about it like how today you are writing logs or metrics or telemetry, right? This is data that you are instrumenting from your code that has nothing to do with the actual business use case that your service provides. You are doing this because you want to create some additional data in the side. In this case, you will have observability. So you can debug things, so you can create monitoring and alerting and so on and so forth. So the idea is, let's instrument the analytical data that is required by our business stakeholders, by our data people, the same way that we would instrument the data that we need, us as developers, to maintain our services. And obviously, once we've defined that, we can create these as events, and then we, in the same way we've done before, consume them into our analytical system. So how does it look? So the business flow actually starts differently, right? It doesn't start with the developer. It starts with the people that are looking for answers. So those can be business analysts, data scientists, it can be your boss, right? And they define the data that they are looking for. And what they do the exact opposite of what we did before. Instead of having the catalog populated by something that the developer defined, they are going to the catalog and defining what data they only wish they could get. So this is how it looks at Wix. This is actually the old version. We have a new version. I haven't had a chance to update the slides. But the idea is basically it's still domain driven, right? So we have multiple domains, and for each domain we have the list of all the events that we want to track. And I can say, okay, I want to create a new event that will collect the data when a user navigated into my website before they even created a shopping cart. I want to capture that, and I want to collect the information of where did this user redirect from? Or maybe I want to collect some events about the user experience happening in the browser in between navigating between products and adding them, right? So I will define them there. I will say, okay, these are the fields of data that I need. I need to know who the user is. I need the IP address because I want geolocation, refer, everything. Like whatever it is that I can capture. Some of that I might have in the context of the browser. Some of that might need to be collected by code. And that's great. It's like, okay, this is the data I only wish I could have. But now comes the big problem. That's cool. I understand that you want this data, but how do we actually get the developer to instrument this data from their code? Right? That can be an extremely fragile thing. So this is where we need to do some magic. And the way we do the magic is by generating an SDK. So basically, when we have this catalog, we know how the data looks. Right? We have a good definition of the schema, which means that we can actually generate code that represents in whatever languages that we're writing, let's say TypeScript, if this is running on the browser, we can generate data objects, classes, that represent the data that we want. And if we're using TypeScript, it's relatively safe. So we can generate this code, purposely built for instrumenting this data, package it in an SDK, and then have the developer integrate it into their code. The same way they would integrate logs and metrics and telemetry. So the way it looks is the developer will just go to our system, they'll copy the snippet of code, even some snippets for unit tests, because we love tests, and then get this experience in their IDE, which is amazing. It's basically the voice of whoever it is that asked for the data carried into the IDE saying, look, we need to capture the event of navigating into our shopping cart page, and this is the data you should collect here. And obviously, in the future, if we will need more data, we'll generate a new version of the SDK. The developer will pull the new version of the SDK, and we'll basically get a compilation error that will tell him, oh, OK, there's a new field that needs to be added. So now we're instrumenting the data. And once this code goes live and start actually emitting this data that we asked to instrument, well, from this point on, it's pretty much the same thing, right? We have a generic pipeline that is aware of all the events that exists across all the domains, the new ones, the updated ones, and it can just connect into the source into which all these systems are now transmitting the data, collect it, clean it up, organize it, put it in tables. Easy peasy. And now we can take all the data that we've collected about our lovely shopping cart, both from our backend and our front end, the data that was defined by the developer, the data that was defined by the analyst looking for the data, and get something like this. Right? So these are our eyes. This is how we can start the process of understanding what do we need to change in our business. How does it look in terms of architecture? Pretty straightforward, pretty much the same thing. So instrumentation can happen on the client side and can happen on the backend side. If it's happening on the client side, then the data will be transmitted over HTTPS to a service API. That will be collecting the data and transmitted downstream into Kafka. If it's happening in the backend, then it's just going to be collected and transmitted into Kafka in the backend. And from that point on, pretty much the same thing. You have a pipeline. In our case, it's a mix between Kafka streams and then later Spark streaming that collects the data, keeps updating itself with the new schemas of all the new events that are being generated and updated, consume the data, do all the cross-cutting concerns, send it downstream, and again, create it as tables in our data lake, S3, Parquet, and Iceberg. Now, if you want to build this yourself, I actually have good news for you. So obviously, you can build everything by yourself. But there are platforms and frameworks out there that, well, nothing does it exactly the same, but do a pretty good job in doing something very similar. I'm not affiliated with any of those. Some of those are open source. Some of those are very much not open source. But basically, these are all platforms that roughly do the same idea, right? You define what data you're looking for, and then it gives you the tools to instrument it into your code, and then later collect it and do analytics on top of it. Cool. So zooming out for a second, what did we do? We understood the paradigm of the awful data recycling center, and we looked for a way out. And the way out for that was shifting the responsibility. Shifting the responsibility on defining data, turning it into a first-class citizen as much as possible to the left side. Why? So that we can take care of the data and the governance and the quality in the place where the domain is managed, and there we'll have an agreement, a contract with the person or people that are, or systems that are looking to collect this data. And that enables us to do a lot of things. We can create documentation, we can automate a lot of processes, and leave out a lot of time to do, well, smarter things, better analysis, training machine learning models, and so on and so forth. Now, obviously, clean data is just the beginning. When it comes to data platforms and data architectures, it can get very complex, if you remember the iceberg that I showed at the beginning. But having this foundation, which is slowly becoming a standard or an expectations in modern data platforms, is the platform from which you can grow into further and more interesting places. So once you can have data contracts, and you can use those data contracts to do automatic data ingestion, then you can also do automatic data processing. You have data that is trustworthy, so you can build machine learning models on top of it. You can use it as input for AI models. But all of this is for another time. I will remind you that another time is next month. We are doing a meetup in our Wix offices next month together with Startree. We will actually be talking about some of the stuff that I presented to you and a lot of things that happened afterwards. especially real-time analytics, both for internal use and for customer-facing use. So if you are interested in that and you want to learn more, then I highly recommend for you to come. And that's it. Let's go to questions. Cool. I need to get closer for this one. How do you deal with falsified data collected at the client side as the collector totally under user control? So there's various types to that. So first of all, you need to think adversarially about anything that is sent from the client side, right? This is something that's very specific. Now, when you think about it, as long as a user is authenticated and has a context that is not able to be falsified, and that's, by the way, true for anything that happens over API. Why can I trust a user is because I have a token and I can verify that that's a specific user. So the worst thing that the person can do is falsify their own information. In reality, there's other things that are happening in between to try to block things like brute forces and DDoS attacks and garbage data and everything, right? But eventually, when you think about it, like the line between falsified data and just user doing random stuff in the UI just to confuse whoever it is that's going to track that, it's not very different, right? So if the only thing I would want to do is to confuse whoever it is that's looking at the data, like what am I doing, then I can just randomly, navigate back and forth. But the short answer is basically anything that you would use to validate any type of API-based user interaction, that applies here as well. What tool are you using for data contracts? So we are using tools that we built ourselves, then that's true for various reasons. So we are defining the contracts depending on the use case. It works differently for each one of these strategies, either through protobuf or using the system that generates something from that is slightly different, right? It's more binary. This is being saved and persisted into schema registries that we build ourselves. Even though Wix is using Confluent, we are not using, at least at this point, Confluent schema registry. And then the validation is basically our code, right? So for example, if you would imagine both the producer and the consumer side, they have sets of libraries that package them to make sure that the data that's being generated is what the contract says, basically. And a lot of that is compile time. You just generate a data class based on the data contract, and then you just validate it during CI. So you just make sure that there's small margin of error. And then on the consumer side, you basically take the schema and then do validation based on top of that. There are more complicated things that have to do with validation that go beyond field level. So things like rules between fields. So if this field is that, then this one can only be something like that. This is something that we don't really do on the streams for various reasons. And we usually do this type of validation post factum. And that's more in the world of data quality tests. So we basically will run some kind of sample tests on the data just to make sure that logically, if there's like complicated logical rules, the data still applies to them. And the reason for that is because sometimes these rules can't be done on a single message level, right? Sometimes you need to do it in bulk. I hope that answered the question. Cool. Thank you all. Thank you for having me. And I'll see you all in the closing notes.